Hi, this is section 1.2 of geometry, finding angles. People use angles every day, I have written down here. Plumbers measure the angle between connecting pipes to make a good fitting. Woodworkers adjust their saw blades to cut wood at just the correct angle. Air traffic controllers use angles to direct planes. And good pool players must know their angles to plan their shots. So angles are an important thing to know in life. So here's the official definition. An angle is two non-collinear, not in a straight line, two non-collinear rays called sides having a common endpoint called a vertex. So here's the vertex, and they have two rays, this one here, AP, and this one here, AT, connected at that vertex A. So those two rays are called sides, and where they connected that's called the vertex. When I name the angle, the vertex must be the middle letter, and the first and third letters must be points on different rays. So I could call this angle TAP. I could go the other way and say it's angle PAT, or because there's only two rays coming together at that one vertex, I can also just call this angle A. Oops. Okay, here's more about naming angles. That's angle either ABC or angle CBA, or again, because there's no confusion about that angle, you can also call that angle B. Here we have some confusion. If I call this angle B, you don't know if I'm talking about this angle in here or if I'm talking about that angle in there. So you have to be careful how you name this. So there are actually in here different angles. The first one is angle DBA in here, and then there's angle ABC in here, and then I can name the whole angle DBC from here to here, but I cannot name it angle B. And this is a mistake that geometry students will make throughout the entire year. I've had people on the final exam lose a point or two because they're naming angles incorrectly. So if there's more than just two rays that come together at a vertex, there's confusion as to where that letter B is applied, and so therefore you have to be careful. If there's more than two rays coming together at a vertex, like here, 1, 2, 3 rays, you can't name it with a single letter. Sometimes you put a number inside, and you can call that then like angle 1. That's another way to name angles. And sometimes when you have a zillion angles that you're working with, that's a convenient way to do that is just to name them by numbers. Okay, which angle is larger here? It says the measure of an angle is the amount of rotation about the vertex from one ray to the other. So when I go from this ray and rotate it to this ray, I have to go a further distance than when I rotate it this way. So therefore, angle A is actually going to be bigger than angle B. Even though these rays, like in angle A, the rays seem shorter than the rays in angle B. But remember, rays have no end, so it doesn't matter how long you represent the ray. So what we're really worried about is the rotation. And we measure in degrees in geometry class. And angles in geometry are between 0 and 180 degrees. So 0 would be when the two rays are on top of each other, and 180 degrees would be when one ray comes over here, like that. So the angles in geometry are between 0 and 180. A protractor is a tool for measuring the degrees in an angle. I'm sure in grade school some of you have used this. Step 1, if you're going to measure an angle, place the center mark of the protractor on the vertex. Sometimes there's a hole, and sometimes it's just a mark, and sometimes it's like where some line segments come together. So on this protractor, I would place that center on the vertex of the angle. Line up the 0 mark. So here's the 0 mark here with one side of the angle. And then step 3, read the measure. So if I'm measuring this red angle See how I put this center at the vertex? See how I lined up this ray with the 0 mark? And then I read on the other ray as to what the angle is. It says be sure that the scale that has the 0 mark is the one that you're using. So here's 0, so I go along here, and I read it's at 34 degrees. It's not reading on the 180 because that would be going backwards. So you always read from 0 to the ray. Congruent angles are two or more angles that have the same degree measure. So here they have angle DOG is congruent to angle CAT, or the measure of angle DOG is equal to the measure of angle CAT. Either of those ways of representing this are fine. Notice how they have a little arc mark there, and then they have a tick mark. So the same tick mark over here. If you want, you can use 2 tick marks. If you want, you can use 3 tick marks each to show. It doesn't matter. An angle bisector is a ray that goes from the vertex of an angle. So this is angle ACB. Here's the vertex C. If I want the angle bisector, it's the ray that starts at the vertex of the angle. So it starts at C and goes so that it divides. So here's the ray. So that it divides this angle into 2 congruent parts. This part and this part. And here, these 2 angles, 43 degrees and 44 degrees. So GE, ray GE, is not an angle bisector. And here I have 52 degrees and 52 degrees. So this ray splits angle SRQ into 2 equal parts. So therefore, ray RP is an angle bisector. And here we have 2 equal angles, but you see that there is not a ray splitting them. There's like 2 rays that are splitting them. So that is MN and MO are not angle bisectors. This is a simple problem. You have a slice of pizza. It has a central angle that measures 140 degrees, and you want to share this with a friend. So 140 degrees would probably be like here. This is 90, so 140 is like about here, okay? And she cuts it through the vertex into 2 slices. It doesn't say that 2 slices are equal. In fact, it says one of the slices is 60 degrees. So if this is the 60-degree angle and the whole angle was 140, then I would subtract 140 minus 60 to know that that angle over here, or that pizza slice over here, is 80 degrees. Okay, this is an important principle in geometry and in physics, and this is used a lot. When a ball bounces off a pool table's cushion, the incoming angle, so here's the ball, I hit it so that it hits this cushion. The angle between the side of the pool table and that line that the ball took to get to that cushion, this angle in here is called the incoming angle. When it hits the cushion, it bounces off here, and the angle made between the side of the pool table and that ray that shows the way that it's leaving the pool table, right there, that angle is called the outgoing angle. And here's the important fact. The incoming angle equals the outgoing angle. So this does not only work in pool, but it works in like sound waves and other things in your life. So a sound wave will bounce off an object in a way so that the incoming angle is also equal to the outgoing angle. So there are zillions of applications of this principle, and we'll be using this a lot in geometry class. I'm going to go to the answers here for those 2 slides. So it says, use your protractor to find the measure of angle 1. So here's angle 1 made by this ray, and we measure it, and it's 40 degrees. Which is the correct outgoing angle? Which point, A or B, will the ball hit? Okay, so the outgoing angle, we measure angle PCA. So here's PCA, and we find also that that is 40 degrees. So if this incoming angle is 40 and this outgoing angle is 40, then the ball will go here and hit at A. Now we're going up on the top part here. Which point on the cushion, W, X, or Y, should the white ball hit so that the ray of the outgoing angle passes through the center of the 8 ball? So we want to hit this 8 ball. Okay, so it says angle BWQ, I should say. Here's B, here's W, and here's Q. When we measure that, that's 70 degrees. When we measure from Q to W to the 8 ball, that is also, over here, 70 degrees. So since the incoming angle is equal to the outgoing angle when we hit at W, we know that the answer to this is you should aim at W. So I went right to the answer. Actually, I'd probably have to measure, that was a lucky guess here because I knew the answer, but I also could have measured this angle in here or this angle in here and seen that if I had done those outgoing angles to the 8 ball, I would have not gotten incoming angles equaling outgoing angles. So that is the lesson for section 1.2.